Good morning. Good afternoon, everybody. Thank you very much for joining our webinar today, co-presented by Aviatrix and Intellyx. Today, we're going to be talking about a subject that is incredibly close to the thing that I am passionate about and work on every single day, and that is how can we secure workloads in the cloud with things like zero trust principles. We'll do a quick introduction in just a second, but I'm out here at reInvent this week. And it is amazing how the technology landscape has shifted over the last several years, especially and in many cases driven by AI. And there's a lot that we could talk about in this space. We'll talk a lot about fundamental principles and how things are changing. But there are two things that we'll look at. One is how can you as a security organization prepare for the age of AI so that you can help defend yourself against AI-oriented attacks, as well as secure the AI that's being used inside of your organization. So before we jump in, a quick introduction. My name is Chris McHenry. I am Chief Product Officer at Aviatrix. I have been in the networking and network security space for a little over 20 years. Spent a lot of time at Cisco. For the last 10 years, though, my core specialty area has been on workload security. How can you use the network and network principles to secure the things that run our applications and ultimately our businesses? And it has been crazy how that landscape has changed over the last 5 to 10 years. We've been going through the migration from traditional data centers from virtual machines all the way to cloud. And now we are entering the AI era, and a lot of those AI agents are going to be running as workloads inside of your cloud. So both it's been a core focus of mine and a privilege to be able to continue to help shepherd people through this transition. And I'm partnered today with Jason Bloomberg. So Jason, I'll let you introduce yourself real quick.
Well, thanks, Chris. This is Jason Bloomberg, Managing Director at Intellyx. We're a boutique analyst firm. We focus broadly on enterprise digital transformation topics. So that includes cybersecurity as well as AI and many other topics like cloud-native computing. So for vendors like Aviatrix that don't fit neatly into the big analyst buckets, we help them tell their stories of value to their broad audience without having to fall into one category or another.
And Jason, I know we're going to talk a little bit about zero trust today. It's really interesting because zero trust has been around for 25 years, I think, and taken a number of different forms. It gets applied in several different layers of the stack as well. It can get applied in the network layer. It's oftentimes talked about a lot in the application on the identity layer of the stack. But it does, I think, also have this perception sometimes of being hard or like taking your vitamins. And all that being said, I've seen it become like really, really a lot more popular over the last couple of years. Again, it's like it's getting reinvigorated. What have you seen?
Well, it started off, back in the 2000s, really focused on human identities. That a human would log in with their username and password, and there was some level sort of concept that their interactions now were secure. And organizations realized that you needed more than that, right? That every endpoint had to be secure, and that's really the core of zero trust, is that endpoints had to be secure. But what's happened in the last 20 years is that identities are more than just associated with human beings. They're now associated with what we call non-human identities. So those could be various kinds of application endpoints, microservices endpoints, and now AI agents are also endpoints that now can take action on the network. And so the challenge of zero trust is basically saying that each of these endpoints has to take care of its own security. You can't rely upon perimeter-based security anymore because every endpoint needs to take care. It needs to address its own security. And in a hybrid environment where you're mixing on-premises cloud assets of various sorts, then zero trust becomes even more complex, but also more important.
Yeah, I think and the shape of the perimeter has fundamentally changed. We'll talk a little bit about that in a minute. But it is, it makes it even more important to think about how do we push those controls down closer to the workloads. So why? I think this is one of the big challenges. Actually, there was a really interesting study that was pushed out it is present in a number of different places. But looking at the rise in vulnerabilities over the first half of 2025, when we look at it at the beginning, right, there's almost 20,000 new vulnerabilities that have been disclosed just in the first half of this year, and it's continued to accelerate. I was reading an article maybe 3-4 months ago that was published by one of the former leaders at Wiz, and they were looking at some of the biggest pain points that we see in organizations and CISO organizations specifically. And two things came to the top of the bucket. The first one was vulnerability management is a big pain point, and the second one is policy management is a pain point. And they're both incredibly complementary, but they both fall into this bucket of how do we land good hygiene to prevent attacks from really happening in the first place. And I think one of the things that we are seeing now as AI has continued to develop, there's a really, really fascinating, we have crossed a threshold in cybersecurity, especially as it relates to AI. Several weeks ago, Anthropic published a study on their first known mitigation of a cyber espionage attack that was almost entirely driven by AI-centric tooling, almost entirely automated. And one of the notes that stuck out to me in their report was that the techniques that were being used were very advanced, but pretty typical, right? We were thinking about getting some sort of initial foothold into an account and then moving laterally. But they were being executed by a machine instead of a human, and so the speed at which attackers are going to be able to operate, I think, is going to be exponentially higher in the world of AI, which means that we need to think about how do we maintain hygiene, and we can't just look at that in the context of vulnerabilities. There's multiple different layers of the stack, and that's really where zero trust comes into play. So you mentioned, Jason, a little bit about the perimeter changing shape or dissolving and needing to think about how do we apply zero trust principle to workloads themselves. And I think it's sometimes helpful to have a visual here. So again, going back and looking at what the shape of the perimeter looked like, 15 years ago, there was typically in this drawing a firewall, a hard line between the employees and the users that you trust and the internet. And over the last several years, the shape has really fundamentally changed to the point where in many cases, the internet feels like it is the enterprise network. It's not entirely true, but it is so much easier. And maybe more importantly, it used to be a single physical cable that you could cut, and now it is many, many, many distributed entry points. So you have at least one entry point to the internet in every single cloud in every single region, and it makes it incredibly difficult to solve. That being said, we know that network security is an incredibly important part of our cybersecurity posture. We know that being able to control how trusted entities in your organization communicate with other trusted entities or untrusted entities, whether it's riding on your physically owned network or riding on top of a virtual network or, even on top of the internet, you still need to be able to control that. And so we have seen a ton of innovation in this space, right? It used to be physical firewalls that were doing this. Now it's SASE, pioneered by Zscaler or Netscope and Cato and a number of the players there, but really focused on how do you reinvent the concept of the firewall for a mobile workforce. And Zscaler has done a spectacular job of helping to elevate the zero trust conversation. On the right-hand side, we have these untrusted users, right? Things that are coming in, accessing our websites, buying things off of our, portals, and if you're maybe checking their medical records, things along those lines. We have to secure that as well. That used to be a physical box from F5. Now that is, it's web app and API protection in the cloud from vendors like Cloudflare, right? So it's as a service, but again, it's a rethinking of what that network security looks like. And on the lower left-hand side, this is a place where we've seen massive shifts in the shape of the perimeter as well. It used to be a physical data center. Now it lives inside of the cloud. The problem with this is that we really have not evolved the platforms and the architectures that we use to secure these workloads. And I cannot tell you how many organizations I see that still do not have good lateral movement control in the cloud, that still do not have good basic perimeter security in the cloud. And it's because the developers have changed the way that they deploy applications. They're aligning with the cloud operational models, they're aligning with the cloud architectures, but we have not kept up as network security teams. That second complaint that you oftentimes hear about policy management, go ask one of your developers what they hate most about their security posture, and they will talk about the time it takes for them to add firewall rules into the environment. That being said, really, really important. And I think if we want to cover this, we do need to rethink a little bit about it, what it looks like. And this is what Aviatrix has been building with what we call the cloud native security fabric. But it's really about how do I apply network security and zero trust principles to workloads in the cloud that live in this ephemeral world, that are no longer just virtual machines, that probably can't have agents installed in many cases. They're running on Kubernetes, or they're serverless, or they're PaaS. And we need to be able to secure these. And so the shape of the perimeters changed, but we have also seen a lot of innovation in this space, and we need to figure out how to adjust that. So why is zero trust important? I think it's always important to take a step back and look at the perspective of the attacker, right? So when you think about how an attack operates, and again, I'll go back to the article that Anthropic put out several weeks ago on the fully automated or largely automated cyber espionage campaign. They all follow a similar technique. The difference is that this time it was just automated and it was moving significantly faster. But there are two general frameworks that many organizations use to help understand what the attacker is seeing. One is MITRE's attack matrix. The other one is a much more simplified view of something called the cyber kill chain, or the Lockheed Martin kill chain. And this is what we call the unified kill chain. I wouldn't take credit for it. It's kind of a combination of the two models, but it makes it really simple, right? It says, that at some point in time, there's a phase where the attacker gets in, then they're going to move through your network, and then they're going to try to get stuff out of your network. And we want to be able to stop things early in the kill chain, but we need to have controls at every phase of the kill chain. And so when we think about, you can apply these principles in many cases to the exact techniques that were used in the Anthropic example. But in many cases, when you zoom in here, one of the biggest challenges that we have as organizations is that our current approach to cybersecurity is really about detecting bad things. You think about EDR, XDR, you think about signatures, you think about threat intelligence, you think about URL categories and reputation and all of those kinds of things. And those are powerful, but it's like it's an infinite problem, right? You're trying to defend yourself against all of the potential unknowns. And that's why we've put so much trust in cybersecurity vendors, but ultimately it's a losing battle. And so zero trust really takes the opposite approach. Instead of thinking about how do I prevent all of the infinitely possible bad things from happening, how do I focus on the ability to only allow the good things so we can turn it from an undefined problem to a well-defined problem? The important part about this is that it's not just about stopping lateral movement. It's not just about preventing things from exfiltrating data. Even at the very early phase of an attack, especially when we're talking about workload, there are multiple scenarios where we can stop the attacker from really getting into the environment just by leveraging zero trust network security principles. Another excellent example, and if you're in the cybersecurity space, I'm sure this was top of mind. There was a round 2 of what is known as the Shy-Hulud worm, which is a fascinating attack on workloads. Strongly recommend that people research it. We put out a blog on the first round of this in October, and we'll be putting out another one next week about how Aviatrix could help stop it if you have the appropriate zero trust policies in place, as well as help do forensics and you mitigate any future damage. But when we think about getting in that example, one of the first things that happens after the malware is, after it was a supply chain attack, inserting into trusted NPM packages that your developers are using. And then the next thing that it does is it reaches to GitHub and it reaches out to another kind of less popular JavaScript runtime and downloads, not malware. You've already downloaded malware, but it downloads things to help it execute the malware. Very definitive attack signatures. The kind of thing that is also trusted. If you're looking at threat intel and reputation, GitHub is trusted. The location of downloading this, they didn't download malware, they download a trusted executable, bin.sh, to execute the malware. All of these would bypass every single traditional threat-based network security approach. Now, you probably shouldn't be accessing GitHub from a public application environment. You probably shouldn't be downloading new runtimes when you have golden images and you have containers that are built. Things that should be blocked in a zero trust environment. And if you block those, you stop Shai-Hulud. You stop a lot of those types of attacks by adopting zero trust network security principles. So it's really a flip in the philosophy. One more thing that's really important to consider as a part of this is workloads are different than users. And we have different stakeholders. So one of the things that I talk to a lot of teams about is it is really, really important, especially if you feel like this has gotten a little out of hand in your organization. In many cases, it has. You might even say like, "Hey, that's great. I have firewalls in the cloud," but the cloud teams are constantly moving. And one of the examples of things that are happening is they're refactoring their applications. They're moving to Kubernetes. A lot of the agentic AI workloads are going to run on Kubernetes and serverless environments. And in many cases, as those applications get refactored, your firewalls are getting dumber and dumber without you really doing anything because they can't see what app is actually acting on the network. It's masked by being natted out of the cluster or natted out of the VPC or the VNet. So cloud teams are moving. We have to move. And we have to, as security teams, we need to be able to find ways to say yes. We need to work together with the cloud teams. We need to embrace the operational model. Because if we can do that, we bring these two teams together, then we actually can create a better experience for both teams, and we can create a better cybersecurity posture. So my number one piece of advice when I talk about zero trust is that in many cases, it's a human problem. And it's important for us as cybersecurity professionals or as cloud teams to find ways to find solutions to problems that can embrace both of the requirements of both the teams, because they do exist. They're just probably not the same thing that you did on-prem. And the last piece of this about workloads is they are incredibly complex. So not only are we seeing a shift in the types of workloads that we have, so moving from VMs, where you had really good control over agents, things like that, containers, where you don't really see them nearly as well, and you probably don't have as great runtime security. You servlet, where you have no runtime security and can't do them on the network, and at the same time, we're looking at different clouds, and every single cloud and every single workload has a different control. We have to find a better way. It's really an architectural challenge, and if we do nothing here, it's only going to continue to get worse. So we won't talk too much about the Aviatrix products, but this is really what we designed the cloud-native security fabric for. It's a way of unifying all of the security controls, following zero trust principles to allow you to quickly improve your cybersecurity posture in the cloud. I asked one question, recently, there's plenty, unfortunately, many examples of this, but when you think about the Shai-Hulud malware, the quick question is, do you know every place in your cloud environment that's accessing GitHub directly? Could you block any requests to bin.sh if you wanted to? And in many cases, the answer is no. So the cloud native security fabric allows us to take our existing cloud environments or net new cloud environments and blanket network security on top of the cloud in a way that aligns with cloud native operational models, is designed for infrastructure and policy as code, and allows us to implement zero trust policies for perimeter security, macro segmentation, and micro segmentation for all types of workloads. For Kubernetes, we are releasing serverless in the next couple of weeks, and for your traditional virtual machines, we're in a way that the cloud teams and the app teams are going to love, because it follows that cloud operational model, but it gives you as a security key traditional network security control. So with Aviatrix, you can have different portions of the policy that are distributed to different app teams and start to shift policy left while maintaining those guardrails, and actually have multiple different what we call rule sets inside of the policy. Some of them could be programmed with Terraform. Some of them could be programmed with our new Kubernetes CRD. Some of them could be programmed by the InfoSec team using traditional threat intelligence. So we can start to blend what that looks like. We can discover what's going on in the environment. So we can start to baseline, implement, and recommend policies to help you improve your zero trust posture. We also are, like I had mentioned beforehand, we just released our Kubernetes berries. So we talked about Terraform in many cases, but we were at KubeCon a few weeks ago and launched a new way of programming policy where you get to meet the developers where they are and actually allow them to contribute to their security posture, not just within the Kubernetes environment, but between the Kubernetes environment and other services. Like maybe a Kubernetes workload is trying to access an AI service in Bedrock, or maybe the Kubernetes workload is trying to access, another service on the internet. It's cluster to cluster, cluster to internet, cluster to other types of workloads. It's one of the places that are really, really challenging with other solutions. So all of this is about how do you meet the developers where they are? How do you shift left? How do you embrace infrastructure and policy as code so that we can get better security, so that we can operationalize zero trust? Because this is one of the biggest challenges with zero trust, and ultimately improve our cloud security posture. We won't talk too much about this, but this has been something that has been really, really interesting for our customers. We've got a lot of collateral, but our Kubernetes firewall offering has continued to mature over the last year. Really, really helped solve some key challenges, solving things like CIDR overlap in Kubernetes environments while simultaneously maintaining effective security, visibility, and posture. So again, when we talk about a workload, what is a workload? It's the thing that runs the applications. Workloads take various forms. When they move to the cloud, many of them are modernized. And we need to be able to secure our Kubernetes workloads at the speed of Kubernetes, but with the quality that we had with traditional legacy workloads. Lastly, one thing that is a big challenge for organizations when they're approaching a zero trust environment is that project and trying to implement that where they don't have it already, is understanding where to start. You can't boil the ocean. You have to know where to start. And understanding risk is really, really important. We just launched what we call our workload attack path assessment. And this is leveraging some really, really innovative AI analysis of traffic in the cloud environment. And you can run it even if you're not an Aviatrix customer today. It's free. It leverages VPC flow, read-only credentials, logs, native logs from AWS and Azure. And it can help you uncover the places where you have the riskiest network behavior in your environment. Now, part of this might say, hey, I need to go stop that. I need to stop access to GitHub from a production environment. But it also is an excellent place where you need to implement compensating controls. So you might have access to GitHub. You can block bin.sh, which is the other indicator of compromise for the Shai-Hulud example. What's really unique about this is we're not just telling you where you have to understand risk. You have to take into context the applications. And so what's incredibly special about what our algorithms are doing is they're discovering your cloud environment. They're understanding what apps are running based on all the metadata that we see from your tags and attributes and accounts and Kubernetes workloads. And we start to build an automated AI-driven application registry that understands things like lifecycle as well, and can then analyze network traffic against the importance of the data and the applications in your environment. So it helps you prioritize where you have the riskiest behavior, not based on some generic threat intelligence, but based on your app environment. And that is available today from our website. So with that, we've talked a little bit about zero trust. We've talked about some examples in the industry where workload security is becoming incredibly important, where the workload landscape is changing. We talked about how AI is influencing the attacker. We talked a little bit about how modernized workloads are going to be the source of agentic AI when Kubernetes is accessing Bedrock as an example. And we need to be able to prepare ourselves for what the explosion of agentic workloads coming in the future. They are going to move fast. And that means that we need to be able to put preventative controls in place. And it is an opportunity for us to reconsider and accelerate zero trust projects. But I know that there's probably a lot of questions here. Before we get into the QA, I did want to pass it over to Jason. So Jason, you've been in this space for a long time. You've consulted with a lot of enterprises. You've consulted with a lot of really, really innovative tech startups. What have you seen around workload security that's been uniquely interesting to you in the last 6 months to a year?
Well, and one of the primary considerations for any organization is their threat surface. And the notion of a threat surface has evolved dramatically over the years. I mean, before the internet, it was very simple. There were, everybody inside the firewall was trusted, everybody outside was untrusted, and the firewall did everything you needed to do. Then the internet came along, and now everybody could go through port 80, and now all of a sudden there's this big hole, and that created a hole in the threat surface. And over time, we've added additional holes in the threat surface. As we moved to cloud computing, there were more holes in the threat surface. As we moved to Kubernetes and cloud native computing, we had additional holes in the threat surface. And now when we're talking about adding AI, we've punched even more holes in our threat surface. So now it doesn't even look like a surface anymore, right? It's just a bunch of holes. And if you look at what the vendors are doing to address this, there's vendors, you mentioned a few of the different categories. There's the CNAPP players and the SASE players and SSE players, and they're all tackling part of the story. They're locking down cloud access or locking down this or locking down that. But it's very difficult now for the cybersecurity buyer to understand, well, what are all these tools that I need and how do they all fit together? And most importantly, what holes will remain, right? Are these all going to plug every hole in my threat surface? And one of the challenges that they all face is the lateral movement challenge. And you mentioned this when you talked about the MITRE attack framework and the how attackers have the three phases. They have to break in, they have to move laterally, and then they have to exfiltrate whatever it is they're looking to steal. So that lateral movement phase is especially difficult because traditional tools typically don't deal with data in motion. They're dealing with data at rest as opposed to data in motion. So it can be very difficult to secure when the adversaries are moving laterally. They may be working solely in memory. They may not even have a footprint in the persistence layer at all. So zero trust becomes increasingly important because you have to be able to up your game to protect every single endpoint, whether it's a human endpoint, whether it's a non-machine endpoint like a microservice endpoint, or increasingly now we have agentic AI endpoints. And this is really what's been changing over the last 6 months to a year is the rise of AI agents who are now taking action on your network in a non-deterministic way. So it's basically a fundamentally unpredictable way. You give them instructions in the form of a prompt and they'll go do things. They'll go find tools, they'll interact with tools, they'll make their own queries, they'll do their own research, and then they'll take action based upon whatever the prompt specified. Well, where in all of that is security? And they may be accessing MCP servers, so Model Context Protocol, which has gotten very popular. It's a very simple integration protocol for AI, but doesn't provide any level of security. So now we have additional holes in our threat surface where an agent or really any AI tool, so any a generative AI chatbot or whatever interface you're using, can now access any tool on your network via MCP without any particular security controls. So if anything, the move to AI is making the entire threat surface worse as opposed to locking things down and then making them more secure. So some organizations now are sort of responding very dramatically to this and shutting down. MCP is shutting down access to AI, no more use of public LLMs, that kind of thing. But that's erring to the other extreme, where now you're impacting the ability for people in those organizations to get their job done and to remain competitive as a company. So how do you balance that? How do you balance the need to leverage these new technologies to get your work done, to be competitive, to innovate in your industry, while also providing the appropriate security. And without a comprehensive zero trust approach that covers all of your endpoints, you're just not going to be able to achieve that proper balance. And that's why I find the security fabric from Aviatrix so important. It's because it's a comprehensive fabric. It covers the entire network, both on premises, in the cloud, various cloud providers, virtual private clouds, whatever you happen to have. It secures all of those endpoints, both Linux and non-Linux systems, serverless as well. So you're covering all the bases, and that's really what you need in order to provide this comprehensive response to that perforated threat surface.
So one other question for you, Jason. I know you talked at the beginning a little bit about IAM and identity, and that being one of the layers of zero trust. I know a lot of organizations are using a lot of tools here. There's a huge focus on cloud native identities. There's a lot of people when they think about cloud security that are focused on CNAPP or CSPM, or there's so much stuff that people are using to try to get a handle on this. You guys have done some research. Like, what do you see as the gaps that people are still missing, even though they've put so much effort into some of these things?
Well, if you think, let's focusing specifically on AI and the behavior of agents in particular. If you have an agent take action, it's usually doing it on behalf of some human user who created the original prompt. So somebody asks, ChatGPT or Claude or Gemini or something, asks that AI to do something for that person. And the AI is now going to go try to do that thing for that person. So what privileges does that AI now have? Does it have the privileges of the user? Does it have the privileges of some system within the landscape? Right? Are you assigning privileges to ChatGPT, where now it can do things based upon the privileges it has? Those are all questions you have to answer. So if a user creates a prompt that instructs AI to do something, well, what system should it be able to access? What data should it be able to access? And what action should it be able to take based upon your security constraints, your regulatory constraints, and the business policies that constrain how you want the AI to behave? And all of those feed into this notion of zero trust, because again, you have to secure each endpoint, and each endpoint has to be responsible for its own security.
Yeah, and I think the layered security here is really important because, we all know that identities get compromised. And it's one of the first phases of many attacks. Even when you think about an IAM identity in AWS, what is it? It's a short-lived token that if you get on the workload, you can grab it and go use it in some other way. And so when we think about compensating controls and layered defense in depth, I think one of the important parts is really how do you layer the way that you control those zero trust principles, those zero trust policies. And so having a layer that acts at the identity layer, having a layer that acts at the network layer, it gives you those compensating controls. Even if my identity is stolen, it doesn't mean that I can necessarily access the database because the network isn't letting me. And so we see those being really, really important components of an effective, deep runtime security strategy.
Well, it's complicated by the fact that, yes, you could have a compromised identity, right? So somebody might steal your credentials and go take action. You might have a nefarious inside user, privileged user. Some admin is now disgruntled and does something nasty to his company before he leaves. Or increasingly the case, an agent, you ask an agent to do something, the agent tries to do it and says, well, I don't have enough privilege to do this. So the agent tries to figure out how to escalate its own privileges in order to accomplish the task it's been given. So, which makes it even more important to have this layered security and have the security at the network level, because the network is sort of where the buck stops, right? all interactions, all data flow on the network, and if there's security at the network level, if that's where your zero trust is based, then you're going to be able to lock down even compromised identity attacks.
The sun was quite in my eyes there, but yeah, totally agree with you. So let's go to a couple in Q&A. One of the questions is, okay, so this is one that I get on a pretty regular basis. So do we need agents to achieve runtime zero trust in the cloud? So I love this question because I've definitely worked on solutions that leverage agents. I think it's a pretty common mechanism when organizations were on-prem to use agents to segment and secure and apply zero trust policy for the workloads in their environments. The problem with agents is that they don't have good coverage in the cloud. And lots of reasons why that's the case, but it has a lot to do with the modernization of workloads. So very difficult. You're not going to deploy most likely a sidecar in every single container. In many cases, if you're using it's very difficult to deploy daemon sets, especially privileged ones in EKS, not possible in ECS, right? When we think about containerization. So agents are becoming less and less relevant in the cloud, which is a problem because endpoint security is a really important part of that defense in depth security stack. So it makes it more important for us to think about what the network is doing to help solve it. So we've been very, very intentional about our solution. We want to give 100% coverage to workloads in the cloud. And we do that by applying those principles inside of the network. So we can cover serverless, we can cover Kubernetes, we can cover ECS. And we also want to do it in a way that is non-disruptive to the developers. So no daemon sets, no sidecars, don't change your CNI, use the native CNI, don't deploy a service mesh. All of this is going to be done with effectively a policy enforcement point. You can think about it like a sidecar to the VPC, not a sidecar to the container. You don't need hundreds of them in every single application environment. You need one in every application environment that acts as that uniform policy control point. So summary, no agents. And that, it prevents you from having to manage the agents, but it does also allow you to get significantly better coverage because agents are becoming less and less relevant in the cloud. Okay.
But you're not talking about AI agents here. You're talking about the older notion of agents, like with APM, right? So there's a bit of a namespace collision here.
Yes, that is.
With the AI agents, the question has a different meaning, right? Do we need AI agents to provide security in the cloud? And the question really would be, is there any other way of providing security? And the answer is obviously yes, right? We've only had AI agents for a little while now, and we've had adequate security before that. But what's increasingly the case is that AI agents are being used for providing security in the cloud, and that's going to continue to be the case, and it's going to be more and more the case. Because AI agents can be very powerful in terms of threat prevention and threat resolution and a variety of other tasks within the cybersecurity landscape. So even though they're not necessary, they are becoming increasingly common, and over time will become more and more important.
100% agree with you. And that's why I'm so excited about some of the stuff that we're doing in our workload attack path assessment and the AI now, like we're using actually it's a suite underneath the covers. It's many agents working together to ultimately come to a determination of whether traffic is good or bad, risky or not risky. And
AI agents now.
Now we're talking about AI agents. Yeah, some of our proprietary IP around agentic AI to help empower the cybersecurity teams to improve their security posture. So yeah, great point. The namespace collision has gotten me before. It is a very interesting challenge moving forward. Okay. Let's see a couple more questions here. How do we protect serverless and Kubernetes workloads when they spin up and down too fast? they don't have traditional IPs. There's several questions around the ephemeral nature of workloads in the cloud. So this is really, really important. And it's one of the places where we have, I think it's a fundamental transition for legacy controls from a network perspective. Obviously, you have, there are controls in most of the platforms. Still say there are some places with cloud native workloads where the controls don't even exist very well. Private endpoints being one of those examples. I know they are very popular. I can't stand them. I feel like they're backdoors out of people's networks. But I get it. The other problem with them is that many of them don't have good controls. Other than that, though, you got security groups, you've got network security groups in Azure. You've got, it's probably maybe some network policies in Kubernetes. You've got, a variety of things that you're using to try to piecemeal these things together in addition to maybe traditional firewall policies. Some of them are rapid, some of them are not. Coordinating them is nearly impossible. And that is really one of the biggest things that we bring to the table with the Cloud Native Security Fabric is we designed it from the ground up to be able to respond quickly to those ephemeral workloads. So tying into your Kubernetes environment and listening for changes so that when a new pod gets spun up or something gets deployed, then it automatically, all of the policies get updated everywhere. Even if it's moving to a non-containerized workload that has no idea what the CNI is in the Kubernetes environment. So yeah, very, 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 very difficult to do with most traditional controls. It's definitely something that we specialize in. We think it's a real problem and something that we have a really elegant solution for. See.
So one of the characteristics you didn't mention, Chris, about how Aviatrix approaches this is you leverage eBPF to provide very rapid security, especially within the context of Kubernetes. Now, eBPF is a Linux kernel level technology. So most vendors who use eBPF use it for observability purposes, but Aviatrix is using it for security purposes. So that gives you that very rapid response to any behavior on Linux, including container behavior. But then you also have coverage of non-Linux, Windows and serverless and legacy environments as well. So you really have covered all the bases.
And one thing that I forgot to mention there is it really is not about IPs. You have to forget about them to some extent. We used to look at the IP as a proxy for a workload's network identity. A lot of people who've been in this space for a long time could probably tell me what the IP addresses of your domain controllers were 10 years ago still. People just remember this kind of stuff. That is not the case in cloud, right? So all of your policy, one of the principles of zero trust is that it is identity based. So what is a workload's network identity? Because it's not an Active Directory user. It might be, you talked about machine identities. Yes, in many cases, machine identities, but a lot of them aren't present, right? We don't, go ask any organization where they have good coverage, full coverage on machine identity management. And I've yet to see somebody who's got it fully under control. So there's a variety of things that we have to kind of piecemeal together. There are a lot of things though that are really relevant. So, we look at them as like tags and attributes. What labels do you have? What's coming out of your CI pipeline? What are the things that developers are already doing that kind of indicate what the workload is for? Is it prod? Is it non-prod? Is it, what account is it in, right? Those are accounts are oftentimes tagged or labeled or have independent purposes if you're following AWS best practice. All of those things can contribute to what a workload's identity is so that we can treat it in a way that's dynamic so that you can say dev can't talk to prod and the CNSF automatically figures out what that means. Any other questions? I don't see any more in the chat. So we will, we're running a little bit early, but I think it's been a really great discussion. So first off, Jason, I really wanted to say thank you for joining me today. Really, really appreciate your expertise and your insight and super excited to have you working with us. I think it's such a fascinating topic and such an important one for most organizations to figure out. The last thing I'll say is we talked a little bit about where you can go next with us. So the first thing is we do have many organizations get stuck with zero trust because it kind of implies perfection. It's like, I'm going to get to zero trust, right? Okay. You got to figure out where to start and how to move forward. And so that's one of the big points of our security assessment. We call it the workload attack path assessment. It'll help you see where you have the riskiest behavior in your environment and where you could benefit most by implementing zero trust controls. And then we've also partnered with Intellyx on a white paper. I think that, Jason, you can probably speak to this a little bit more.
Yeah, it basically covers some of what we talked about today. The question of zero trust, and why is it that cybersecurity morass doesn't help? Cybersecurity morass. There's all the 3 or 4 letter acronyms. You go to one of the big security conferences, that's all you see. It's like all these acronyms. It's like you can buy 32 different things and hook them together, and you still have holes in your threat surface. So talk about that and how the fabric approach. I really like the fabric metaphor because it's comprehensive and it's flexible. So that's what the word fabric means to me. And that's exactly what we're talking about here.
Awesome. So either one of these, great next steps, if anything that we talked about today is interesting to you. Thanks again to everybody for your time. Really, really appreciate it. We will post the recording, and if there's anything that Aviatrix can help you with, very, very easy to get in contact with us. Just go to our website, and we hope that all of you have an opportunity to help make progress towards improving your security posture, because none of us are perfect, and there's always something we can do to help improve our risk profiles. Thank you.